7 months. That is how long the ground beneath one of the most closely monitored volcanic systems on Earth has been rising without interruption. Since July 2025, instruments inside Yellowstone's Norris Geyser Basin have recorded continuous uplift, steady, measurable swelling of the Earth's surface. Not a spike, not a sudden jolt, a sustained rise. And now, with more than 100 earthquakes recorded in January 2026 alone, scientists are watching very carefully. This is not speculation. It is not rumor. It is not social media exaggeration. It is satellite radar, ground-based GPS, seismic arrays, gas monitoring stations, all confirming that Yellowstone is changing. The real question is not whether the ground is rising. It is why. To understand what is happening, we need to zoom in on one of the most volatile thermal areas in Yellowstone National Park, Norris Geyser Basin. Norris is not just another scenic stop inside the park. It is the hottest, most acidic, and most dynamic geothermal area in Yellowstone. Surface temperatures here approach boiling. Subsurface fluids can exceed 400 degrees Fahrenheit under pressure. Geysers shift behavior without warning. Pools drain and refill. Entire sections of ground can change character in months. If Yellowstone were to signal internal pressure first anywhere, Norris would be a prime candidate. In July 2025, satellite interferometry, known as INSAR, detected uplift centered near Norris. Interferometry works by comparing radar images taken from orbit at different times. Even millimeter-scale vertical motion becomes visible when the signals are processed. What scientists saw was unmistakable: upward deformation. During the first 3 months, uplift measured roughly 2 centimeters. That may sound insignificant, less than an inch, but here's what makes it important. It did not reverse. Through autumn 2025, uplift continued. GPS stations on the ground confirmed it was not an imaging artifact. By December, total rise in portions of the basin approached 3 to 4 centimeters. By February 2026, the motion was ongoing. 7 months of steady inflation. Yellowstone does not simply rise randomly. The crust moves because something beneath it is exerting pressure. There are 2 primary mechanisms capable of doing this: magma movement and hydrothermal pressurization. Let's break both down carefully. Deep beneath Yellowstone lies a vast magma reservoir system. It is not a giant underground lake of liquid lava. It is a region of partially molten rock interspersed with solid crystals. Only a fraction of it is melt. But when that melt shifts position or increases in volume, it can push upward on the crust. Think of it like slowly inflating a cushion beneath a heavy blanket. The surface responds. However, and this is critical, most modern Yellowstone uplift events have not been caused by fresh magma injections. They have been driven by hydrothermal fluids. Yellowstone is essentially an enormous natural pressure cooker. Snowmelt and rainfall seep downward through fractures. As the water descends, it encounters intense heat from underlying magma. It superheats, it expands, it turns into high-pressure steam and fluid mixtures. If pathways become sealed by mineral deposits, pressure builds. When pressure builds enough, it can physically lift the ground. In the past, Norris has experienced episodes of rapid uplift followed by subsidence, inflation and deflation cycles that reflect changes in subsurface fluid pressure. Between 2004 and 2010, Yellowstone experienced one of its most dramatic uplift periods in modern history. In some areas, the ground rose nearly 25 centimeters, almost 10 inches. Eventually, that uplift slowed and reversed. No eruption followed. That historical context matters. So what is different this time? Duration and seismicity. In January 2026, over 100 small earthquakes were recorded in the Yellowstone region. Most were low magnitude, between 1.0 and 2.5. Too small to cause damage, but clusters matter more than individual quakes. Earthquakes are the crust's response to stress changes. When fluids move or pressure redistributes underground, faults adjust. That adjustment produces swarms. Yellowstone is famous for earthquake swarms. In some years, the park records over 2,000 earthquakes. Swarms are common. They are part of how this system releases pressure. But when swarms coincide with uplift, scientists pay closer attention. The key question becomes, are these earthquakes shallow and fluid-driven, or are they deeper and magma-related? So far, seismic signatures suggest fluid movement rather than magma intrusion. If magma were rising rapidly toward the surface, scientists would expect to see harmonic tremor, a continuous seismic vibration often associated with magma flow. That signal has not been detected. Gas monitoring is another critical indicator. Rising magma typically releases increased sulfur dioxide. Significant changes in CO2 or SO2 output can hint at magma ascent. Current monitoring reports have not identified dramatic gas anomalies. Thermal imaging is also crucial. A surge in heat flow, new steaming areas, or rapid temperature spikes could signal escalating unrest. At this time, no extreme thermal anomalies have been reported. So is this normal? In geological terms, yes. But normal for Yellowstone still means active. Yellowstone's volcanic system sits above a mantle hotspot, a plume of heat rising from deep within Earth. That plume has fueled 3 massive eruptions over the past 2.1 million years. The most recent super eruption occurred approximately 640,000 years ago, forming the current caldera. That number alone drives fear-based narratives. But volcanic systems do not follow predictable timers. There is no geological alarm clock counting down from 640,000 years. What matters is present-day data. Studies estimate that only a small percentage of Yellowstone's shallow magma reservoir is eruptible melt, likely between 5 and 15%. Most of the system is crystalline mush, not freely flowing lava. That reduces the likelihood of sudden catastrophic eruption without extensive warning signs. But hydrothermal systems can still pose localized risks. Norris Geyser Basin has experienced hydrothermal explosions in the past. These occur when pressurized steam suddenly flashes and blasts rock outward. They do not require fresh magma, they are driven by fluid pressure alone. Some past hydrothermal craters at Yellowstone are hundreds of feet across. These events are rare but real, so when scientists say they are monitoring Norris closely, they are watching for signs that pressure could be building toward a hydrothermal event, not necessarily a super eruption. Let's zoom out for perspective. Uplift of 3 to 4 centimeters spread over miles is not visible to the human eye. Visitors walking boardwalks would not feel it. It is measurable only because Yellowstone is one of the most instrumented volcanic systems on Earth. Continuous GPS stations measure vertical and horizontal movement with millimeter precision. INSAR satellites pass overhead regularly. Seismic arrays triangulate quake depths and patterns in real time. If Yellowstone were to escalate toward eruption, scientists would likely see accelerating uplift, increasingly shallow earthquakes, harmonic tremor, and major gas shifts. Those combined signals are not currently present. Alert level remains normal, but normal at Yellowstone includes movement. Yellowstone breathes. It inflates, it deflates, it shifts, it fractures, it steams. The real story here is not imminent eruption, it is persistence. 7 consecutive months of uplift focused near Norris is scientifically interesting because it reveals how dynamic Yellowstone's hydrothermal plumbing system is. If uplift continues beyond typical seasonal cycles, interpretation could evolve. If it slows or reverses, it may simply become another chapter in Yellowstone's long pattern of deformation cycles. Scientists are not issuing evacuation orders, they are issuing updates. Because the purpose of monitoring is not to alarm, it is to understand. Here's the truth that often gets lost in viral headlines. Yellowstone is not asleep. It is not waking up. It is active, and it always has been. The earth beneath Norris is rising. Earthquakes are occurring. Pressure is shifting, but movement alone is not catastrophe. What matters is rate, depth, gas chemistry, heat flow, and trend over time. And right now, the trend suggests a hydrothermal-driven uplift episode within historical norms. That could change. Geological systems can accelerate, but as of February 2026, the data does not indicate an impending eruption. What it indicates is a living volcanic system adjusting to internal pressure. Yellowstone is one of the few places on Earth where we can watch that process in real time. And that is extraordinary, because beneath the geysers, beneath the hot springs, beneath the tourists and boardwalks, lies a system powered by deep Earth heat, constantly redistributing pressure through rock, water, and steam. 7 months of uplift is not a countdown. It is a reminder. The ground beneath Yellowstone is not static, it is dynamic, and scientists are watching every millimeter. The real question moving forward is simple. Will the uplift stabilize or continue? That answer is still being written beneath Norris Geyser Basin, and we will know because the instruments are listening.